So the other video activity, the test end-to-end connectivity, you need to wait for that auto negotiation process to occur. So this is the test end-to-end connectivity 282. So once you first fire it up, you'll see that these links are orange. That auto negotiation process is taking place. So you need to make sure that you wait for that to complete. Once it completes and everything's green, then we can actually do test to end. We can test end-to-end connectivity. So they give you the IP addresses of each device, and IP is how we communicate. So things either use numbers or names. In this case, we're using numbers. So if I wanted to test the connection between PCA and the switch, I should be able to do a ping 192.168.1.2. And you'll see that we should get mostly non-drop packets. So I was trying to figure out a path. Hey, we found the switch can talk to us. So I can connect from here to here. I just tested end-to-end connectivity. So I could test the connection of myself. So there's a special address called a loopback. If I do ping 127.0.0.1, I should get responses. So I just tested the actual IP being bound to PCA. I can also ping the 192.168.1.10, which is the address signed to PCA, and get a response. Well, now maybe we want to check to see if we can get from PCA over to the switch 2. Well, let's see. So switch 2 is 192.168.1.3, noted in the note. And I press enter. And it may take a minute to find the way there, but we should get a result. So after it fails once, and then from now on it should, and you can up arrow so you know, so you don't have to type it again. I can get to that switch. So I can get from here to here and here to here. What about PCB? It's 1.11. So to save time, I'm going to do an up arrow, backspace, 11, enter. And wow, we've tested end-to-end connectivity. Another command that they want you guys to know, traceroute, is also usable. It doesn't really tell you a whole lot here, because when we're trace routing, we're tracing the connection from here to here. We're looking for hops. So this shows that I didn't pass through any routers. I went straight to PCB and came back. When we start putting routers into the middle of our packets, you'll see that we get multiple hops. I'm going to demonstrate this by pulling up a live command prompt. And I'm going to trace how long it takes me to get from my office to Google. So you can see it jumps to a router, and it's going to jump onto your provider network, in my case Comcast, where I'm sitting. And then it's going to probably jump somewhere else in Comcast. And so a lot of times there's names out on the internet, but as we pass through routers, traceroute tells us how many different devices we have to pass through to get to a destination. So in this case, Google. It is probably going to be about 10, 15 hops if I had to guess. See how accurate I am. Eight. And you see we haven't left Comcast network, so they've got a connection from here all the way through into New York. Still on Comcast network. I think we just left. Now we're out on the wild, wild west of the internet. And finally we're there. So it looks like it jumps all the way from South Mississippi up to Tennessee, back to Texas, over into New York. It's shifting around through routers all over the country, and it finally ends up in this address location wherever they have it hosted. But if I had to guess, it's not far from where New York is one of the Google server lands or server farms. Anyway, I hope that helps with what they're wanting you to understand as far as testing interfaces and testing end-to-end connectivity.